Greetings. My name is Jonas Birch. I'm the Senior Director of Applied Technology with Emerson Automation Solutions. We'll start off the session today with a short presentation by me. Next. Standards are incredibly important because they make all the products around us work together. If you think in our daily life, we have Ethernet and USB networking, we got Wi-Fi, we got Bluetooth, wireless. But the networking is not enough. We also have file formats, like JPEG for photos, MPEG for video and music, and HTML for web browsing, okay? And the protocols that transport them. Next. So in the process automation industry, we also have our standards that enable Industry 4.0, and for this purpose, there's been a lot of new standards created over the years, including 5 of them or 6 that we're going to talk about today. Namur Open Architecture, and Module Type Package, Ethernet APL, Hard IP, and Opc Ua. Plus another technology, Automation AML, which is a key part of MTP. Next. So I'm going to start off with Namur Open Architecture. Next. The great part here is the familiar automation architecture with sensors and actuators, and then at the bottom, and then DCS and historian, and then ERP at the very top. Okay. This is a very robust automation solution, and the integrity and security is very important. So we don't want to mess with that, Yet we need a lot of new analytics and sensors to enable the 4th industrial revolution. And that's why the Namur Open Architecture was created. That's the pink sliver on the side there. That's where you can add additional sensors and additional software without disturbing the integrity of the DCS. So it's a very secure solution by having these as 2 separate security zones. Next. And you can see the detail here. So the gray part is the core process control security zone. Okay, that's where your sensors and actuators and DCS sit. Okay, the 2 pink parts, that's for monitoring and optimization. That's what we're adding with the Namur Open Architecture. So these are separate security zones, to make the whole solutions more secure. So in the pink part there for monitoring and optimization, that's where you add on wireless sensors for vibration, corrosion, acoustic noise, and so on. Okay? And on the DCS side, you see the core technology there. Our key technology is Opc Ua that enables data to come from the existing DCS, this new second layer of automation. Okay. Next. So the core process control remains robust. We're not changing that. Next. The new sensors and analytics apps for the 4th industrial revolution sit in the monitoring and optimization security zone. Next. So as a result, we're not compromising plant safety or plant availability. We get an open interface to all of the DCS data. We can add a lot of new capabilities for analytics and optimization in the plant, and we can do it in an agile approach, step by step. Okay? Yet, all of this is done in a secure fashion thanks to the separate security zones. Okay? And all of this is very easy to use thanks to this architecture. Okay? Next. So the next technology is Opc Ua that you saw really at the very core of the Opc Ua architecture. The Namur Open Architecture. Next. So Opc Ua is really like a software backplane. All of the existing systems like SCADA, DCS, package unit PLCs, vibration monitoring systems, all of them provide data up to new apps, for analytics, energy management, advanced process control through Opc Ua. Next. A key enabler for this is the so-called information model, that organize all of this data in all of this system so that it's very easy to get to this data from the new analytics apps. Okay? Next. Okay, and the beauty here is since there are so many systems and apps that already support Opc Ua, you can very easily add and replace systems and add and replace apps to your system, without causing obsolescence. Next. So another key technology is Ethernet APL. Next. So plants today, they use Ethernet, around the ERP, in the office, even in the plant historian, DCS, and even the controllers all use Ethernet. However, all of the instrumentation in the field still use analog 4 to 20 milliamp and on-off signals, and in some cases, maybe some form of field bus, okay? But there is no Ethernet over there. So that's really what we want to change. We want to get Ethernet everywhere. However, there's been limitations of regular Ethernet. Is the distance and it's not intrinsically safe and so on. Okay, and there's a lot of cabling. So the requirements for Ethernet in the field are tougher than what you have in the plant environment. Next. So really now what we're doing with Ethernet APL is providing this capability, two-wire Ethernet in the field for the instrumentation. Next. So Ethernet APL, it can run 1,000 meters. It's intrinsically safe, provides two-wire power, and can run as fast as 10 megabit per second to enable new applications. Next. And it's based on IEEE standards, just like regular Ethernet, but with a new twist. It's using the same cable as Foundation Field Bus, so that's all freely available, and it's intrinsically safe. So it's all based on standards. Next. And many protocol organizations support this technology. The FieldCom Group, ODVA, Opc Foundation, Profinet International, and so on. So all of these protocols can run on Ethernet. And also other things like web browsing is also possible over Ethernet APL. Next. So this is what the architecture looks like. So you can have, from the field junction box, you can have 200-meter cable out to your instrumentation. And from the marshalling panel out to the field junction box can be 1,000 meters, and then or 1,000 meters to the next field junction box. Okay, so it can easily cover even very large plants. So now you have Ethernet everywhere from sensor to port. Next, HART IP, another key technology. Next. So we have used HART for more than 30 years, but it was very slow. So that limited applications, so it didn't get used much. Now we're basically running the HART protocol over Ethernet APL at 10 megabit per second. Next. So this means that you can have Ethernet APL, 4 to 20 milliamp, and wireless HART devices all using the same protocol. So it becomes very easy and familiar to use. Next. But Ethernet APL, of course, enables HART IP, Ethernet IP, Profinet, and many others to coexist in parallel. Next. And it's secure, using TLS, security, and syslogging, etc. So even though it's digital, it's secure. Next. So this is what the complete architecture can look like. So you can use HART IP, but you already use it in your wireless HART gateways, and maybe in your HART multiplexers, but now you can also use it in your direct all the way into your HART IP field instrumentation, and you can use it in or maybe already in your logic solvers to get the data into device management software. Next. Then module type package or MTP. Next. So integrating package units until now has been very challenging because it involves mapping data through Modbus, okay, which means that, which is error prone and therefore also we tend to map very little of the data. So the package units becomes almost blind. But with MTP, we make it a lot easier through Opc Ua to integrate all of the data in the package unit PLC into the main DCS. Next. So that includes all of the alarm management, control strategy, HMI graphics, okay, all of these pieces, they now get full access to the data in the package unit PLC. Next. An underlying standard that enables all of this is automation ML. So this is also another standard that you're going to see a whole lot more of. So with that, you can fully integrate your package units. Next. Okay, so that concludes the background discussion. So next, I would like to get the panel discussion started by introducing the other speakers. We have Antonio Ferraco from TUV SID. We have Michael Kessler from Pebble and Fuchs, and Sharul Rashid from Petronas. Welcome, gentlemen.
Thanks, Jonas.
Right. So I'm going to kick it off straight away. Maybe I'll start with you, Antonio. How is the current adoption well, we start with Namur Open Architecture. How is the current adoption based on your experience with Industry 4.0?
Thanks, Jonas. Thanks for the introduction, and welcome to the other panelists. Can you hear me properly? I guess so. I would like to share with you that we've been within TÜV collaborating with many manufacturers during the last, I would say, 3 years, and doing sort of digital maturity, readiness, trying to understand where the plants or the process industry, most of the process industry were. And we noticed that at the moment, apart the companies that were part of the consortium that developed Namur, the current implementation of the system architecture is not yet there. They are still in the phase of designing. They're still in the phase of realizing how to integrate the OT and IT different worlds. So the many requests and requirements that we received was like developing for them an hybrid system architecture that can help in this transition. So for what I can say that Namur is the North Star, is the ultimate goal, but is not yet fully implemented. It's like the inspiration that most of the chemicals company will be working to, they are trying to move to. But they have also legacy system or legacy architecture that do not allow this smooth change or smooth transition. So this is from our own experience.
Okay, thanks, Antonio. Maybe for you, Michael, how does Ethernet APL help in the implementation of the Namur Open Architecture?
Yeah, as you have shown, one of the core features of Namur Open Architecture is the second channel to get hold of maintenance and optimization data. Mm-hmm. And as a matter of fact, Ethernet APL has that second channel built in. So actually, since Ethernet APL is IP-based technology, the physical layer is capable to support multiple channels. So we will have the communication for real time and the communication for maintenance and optimization, device configuration, and what have you on the same physics, but with two distinct separate channels. And that's something that Ethernet APL will allow for the first time as an integrated and not as a bolt-on solution. The IP-based protocols give transparent access to any kind of interfaces, to open interfaces in field instruments. So from my point of view, able to do proper NOAA.
Okay.
Yeah, I was also wanted to highlight what just Michael shared, is that also that from a manufacturer perspective, the company now realized that the optimization can also be done digitally. Until now, yes, most of the plants, they were basically relying on DCS, that sort of alerts, and were reactive. Using the Ethernet APL, this sort of can increase the agility on the reaction of controlling and also optimizing different tasks within the plant itself. So this is now why NAMO is going to be more important for the plant operators.
So, okay. Yeah. So, Shahrul, in Petronas, you must have had some pretty stringent management of change requirements, right, for your DCS. You can't simply add sensors or add apps or software to your DCS, right? So a second layer like this with NOAA, how does that fit with your plans?
Thank you, Jonas, for the questions. With any other change, this is I call management of change. Any changes, we will have to look at from the perspective of risk. So we have to conduct a risk assessment. What is the impact to the organization, to the process? So we will do a rigorous risk assessment. There's a process to it. So when you want to add sensors, and you have to ask, what is the objective of adding? What will it impact to the neighbors when you actually doing the installation? Will it be affecting the virus, neighborhood virus, for example, that will affect the plant when the plant is running? Should you do it during the plant downtime, when the plant is down, etc., etc.? And those are the questions that will be asked as part of the risk assessment for this management change. Thank you.
Yeah. Okay. So good point. I mean, you mentioned there you might always assess the risk to the neighbors, right? So I think by having two separate security zones, right? That way, you can make changes in the monitoring and optimization side without affecting your neighbor, the core process control side. So yeah, so it's a good solutions for this kind of IoT. Adding IoT sensors and apps. Good. So next, maybe I'll move on to Ethernet APL. So maybe for you, Michael, Ethernet for process automation. Can it replace 4 to 20 milliamp and on-off signals? Is it just another field bus, or what's new here?
Yeah. Yeah. My answer to your first question is pretty short. It's yes. It's my firm belief that at the end of the day, all instruments gonna be IP based. There are lots of benefits of using IP. We have just discussed NOAA. That's one of the many, and that will drive end users, process industries towards using Ethernet APL. I've got absolutely no doubt that'll take a while. Plant lifetimes are pretty long, and we are at the very beginning of that story. If you look into other areas like our offices or our homes, nobody's using a Centronics interface to connect the printer or even USB. All printers are sitting on IP networks, on Wi-Fi or on cabled Ethernet. There is one argument that's about the workforce that has to get familiar with these technologies. My point is that we are looking into changes in workforce. Our workforce is aging today. We will get a new generation of workers in our plants, and these people are digital natives. That means they will come into a plant and will not ask, where can I hook up my multimeter, because they've got no clue what that is. But how can I connect my smartphone to that? Because that's what they are using day and night in their private life, in their professional life, and therefore you see. And we're gonna look into a new generation that's gonna take using such kind of technologies, and not what we're used today. And therefore, the answer is yes. And the second part of your question, is Ethernet APL another field bus? And there, the answer is just the opposite. No, Ethernet APL is not a field bus at all. It is a physical layer. It's a new physics that allows to extend Ethernet technology into plants in the in the field level of process industries to connect field instruments. And it is open for any kind of protocol that is available on Ethernet without any kind of limitation. Of course, some make sense, some don't. But in general, you can watch YouTube videos, you can send emails, but you can also do process control. You can use it for Ethernet IP, for hard IP, for Profinet, for Opc Ua, for browser-based communications. You can use FTP to download documents, whatever. So it's a very it's not a physical layer, but it makes it's a physical layer, not a field bus, but it enables all existing technologies. And there's no need to invent anything new on the protocol level. It's all there.
Right.
May I jump in? I wanted to observe two things and back to what Michael just shared with us. One is about the workforce. You mentioned that the new digital workforce will be more, let's say, focused on more soft, let's say, knowledge related to digital knowledge. I would say they're transforming to having more data science or people that are more related to computer engineering. But do you think that the knowledge of the physical knowledge that is needed will still be needed in the plant? This deep technical knowledge will still be needed in the amount of the people, or just few selected operators just need this knowledge? This is my first one. Okay. And the second one with the Ethernet APL. In terms of adoption, I see that the process industry is starting and testing and willing to implement. But doesn't this also increase the risks of cyber attacks, of OIT ports opening while interacting with the field's assets and so on?
Okay, so maybe for Cheryl, I'll give some input on that later. But first, I'll let Cheryl. Are technicians ready for two-wire Ethernet? The instrument text.
Okay, Jonas, I can answer to Dr. Antonio's question. Anyway, okay. Let me answer his question. His ad hoc question. Okay. Yeah. Okay, you need to make a judgment, the benefits versus the risk. In all cases, there are always risks that come along with the benefits. So the company has to make a judgment. If the benefits outweighs the risk so much by multiple multitude level of degree, by all means, I will embrace that one. But if the risk is actually overwhelming the benefit, I will have to drop that technology. Okay, that's my quick answer to that. Now I'm going to answer Jonas' question. I wish my technician is in front of here, listening to Michael Kessler's explanation of what's the benefits of the APL. After listening to his explanation, my technician will subscribe to that APL for sure. But when it comes to the actual implementation on site, it takes some time for the technology to be deployed, because there are, as you mentioned, Jonas, the management of change, the layer of people that we need to go through, the understanding what is this technology, what is the risk that this technology will put to a patronage, what is the readiness of our staff, our patronage staff in this new technology, etc., etc. We don't want the same thing happen to when we embraced the field bus technology few years ago. We were all excited about this field bus technology, but the risk that the field bus technology put to us is enormous. The benefit is there, but it has a common mode failure, because there are a control loop that is common, 5 valves in one common loop. If that 5 valve fail, I mean, the plant is down. Thank you very much. Thank you. Back to you.
Yeah, so I mean, good points, guys. And that's why I mean, cybersecurity has to be an integral part of the protocol, right? I mean, like IP and some of the others, they do have TLS security, they do syslogging, etc. So that's important for that. Avoiding common mode failure is of course very important. So maybe Michael, you can comment on that. Yeah.
I want to comment on cybersecurity, and because that's a very important point. And my take on that is that if you are operating a plant today, you're about cybersecurity, because everybody is using today Ethernet-based technology, and if you don't take care of that, you're in a deep shit. You've got a problem, and most companies take that very serious. So don't get me wrong. What we do now is we are actually extending the very same protocols that are used today anyway into the field. So actually, the same mechanisms apply. It's nothing new because, as I said before, it's just a new physical layer, and we're extending something that's used anyway. So no difference in that regards. I think it may be even an improvement, simplification, because today plants that are using digital technologies are using different kinds of protocols on different kinds of physical layers, and they're all susceptible to cyber attacks. We have seen people even hacking hard instruments, wired hard instruments with pretty simple measures. And basically, APL makes it possible to worry about cybersecurity only once for one set of protocols, for one physics, and not for many different things in your plant. So if you do it the right way, it's simpler because it's just one kind of cybersecurity, not a bunch of different ways to do that.
Probably, I think I agree with you, Michael, because one of the largest challenges that relates to cybersecurity was now trying to link the overall operational technology within the plant with the old business layers that are, let's say, at the higher level of the plant. If Ethernet APL is basically a common technology that can link the both IT and the IT, then the aspects covered by the cybersecurity covered 360 degrees the whole plant, including operation, including administrative tasks. Because I also am aware about the standards that covers the cybersecurity, like the IEC 62443. I remember that one is purely focused on the all operational technologies. While the IT operations, when they exchange information, there's the risk of some ports opening when the information exchange in real time, and that could be some vulnerabilities. But probably Ethernet APL also addressed this sort of vulnerabilities. So it's a plus for the plant.
Yeah. So the same security that you've been using in your DCS and your PLC and your historian now also applies to instrumentation, right? And then, another big point in the difference between field bus and Ethernet APL is that really in Ethernet APL, the field switch in the field junction box, it basically has repeaters on each individual spur, so in fact, each spur is almost like its own individual network. So noise doesn't propagate from one spur to another, so that makes it very, very much more robust and so much easier to troubleshoot. Okay, so Ethernet APL will in fact be a lot easier to adopt. So
and furthermore, the switch port's gonna provide built-in diagnostics, and therefore will also help troubleshooting. It's nothing separate; it's part of the system.
There you go.
May I ask, because at the moment is not yet adopted as it should. What do you think is stopping? What barriers are from the plant operators or the plant owners stopping them to implement the Ethernet APL? Is a question of being aware about the old safety that is behind this, or what are your thoughts about this? because I don't see the full utilization of the Ethernet APL now in most of the plants.
Well, we're still actually waiting for products to be officially launched. It will still happen within this year or early next year, perhaps, you know. So yeah, you can't buy it yet, I believe, you know. Yeah.
But
yeah, you can buy switches, but no instruments so far.
Oh, okay, yeah.
At the very beginning,
Yeah. Okay, great. So maybe on that note, I'll ask. Wait, let's move to hard IP here. So Sharul, for you maybe. So the instrument techs, you know, they've been using 4 to 20 milliamp heart and wireless heart, you know, like, you know, maybe for 30 years, right? With 4 to 20 milliamp heart. Do you think it will be easy for them to adopt hard IP? What is going to be the reaction from the field there?
Now, if you listen to Michael's explanation, IP is the way to go.
Yeah.
So anything that comes along with IP, I would love it.
Yeah.
So hard IP is IP based, right?
Yeah.
So, well, automatically my technician will love it. Why? Because all the parameters now used to be very limited. You send pressure, you send diagnostic. It's all by a single tag. Tag by tag. But with the IP base, everything is bundled into a package. Into a data frame. So it is very efficient way. Yep.
Yeah.
Thank you.
Yeah. So, well, link back maybe to Ethernet APL a little bit. So Sharul, what do you think will be the main benefits for you as an end user, you know, with IP-based and Ethernet-based field instrumentation?
Okay. Right now, unfortunately, our plant is not built from scratch. Unfortunately, our plant has been there. So it's a legacy. I cannot repeat the parts, you know, and just change. Change with the new greenfield technology. With the, for example, the APL. I would love that one to be changed. But unfortunately, I'm living with a legacy system. So we need to be very careful in selecting adopting those new technologies so that it will not affect the way we operate. Will not confuse the operator, will not confuse the technician. Because they use, for example, 420 million, they're so used. Then suddenly you're introducing something when you want to troubleshoot, you cannot use the analog multimeter anymore. So you need to understand the behavior, you need to understand all this culture aspect. And when you want to introduce this technology, you need to really take that into account, the impact. Again, I'm talking about risk.
So, like Michael said, you know, I think and also Antonio, you know, it's like the new generation will take to this a lot easier, you know, because they are familiar with using web browsers and so on. So maybe Michael, you know, so like HART is an established protocol, you know, in the process industry, but what happens when, you know, all instrumentation moves to Ethernet APL?
Actually, we're going to see. That's kind of hard to predict, but we've seen on your slides that HART is actually independent of the physical layer. So the only difference between HART and hard IP is the physics, more or less. Of course, there's some more, but the basic structure, the handling is identical. And very important point is the HART is well established for device monitoring, device configuration, and maintenance. And therefore, people are familiar with it. And much more important is any control system has a way to support HART. It's very well established to have an asset management system in the plant that uses HART to get hold of to get connection to hard instruments, to their maintenance, to configuration, and therefore HART is a perfect migration path as well for Ethernet APL based instruments, because it's exchanging the physical layer, but not exchanging the way and changing the way how to handle the instruments themselves. And something that was not clear on your slides, or not that clear, is that the APL, I've mentioned that before, is multi-protocol capable, of course, because it's IP-based, and therefore I think that we will have instruments that support multiple protocols, like hard IP, like Profinet, like Ethernet IP. Just mentioning those that are very common today. And that means that we can have a combination of using hard IP to do asset management and other protocols to do real-time communication, because it very well integrates in the existing control system landscape. Therefore, from my point of view, it will absolutely play a very important role when we go IP-based. Depending on the end users and the control vendors, it may even be used for real-time control. Technically, that's a no-brainer because hard IP is supporting that. There have been studies that show that the performance is excellent for that purpose. It's more a matter of is it appreciated by system vendors and end users. So I think hard IP has a great future with Ethernet APL.
Thanks. So let's move on to Opc Ua. So I'll start with you, Shahrul. How is Petronas using Opc Ua? Could you tell us about where Opc Ua fits in your architecture, in your data strategy? What applications is it used for? Yeah.
My first experience with Opc Ua is not Opc Ua, Opc Classic.
So long ago.
Long. So, but it's still there.
Yeah.
I can't really disband it.
Yeah.
It is part of the system right now, especially when we are talking about level 3, the advanced process control, the APC, the alarm management, the controller performance module, the CPM. We require the Opc Classic at that point of time. But when this Opc Ua was introduced, I know they have introduced they call it a wrapper, okay? But with the Opc Classic, then come the challenge of connecting to the enterprise. So we have a workaround. They call it Opc Tunnel. So we have been able to survive within the cybersecurity framework or safe the secure design using the Opc Tunnel. So the Opc Ua at this moment can wait first, until the actual overhaul of the DCS architecture. When the time comes, then I specify for Petronas, the backbone must be Opc Ua. Right now, for example, Group Digital is having this big initiative to pull data, they call it dark data, from the floor level all the way to the enterprise. We want to build what they call enterprise hub. With the enterprise hub, we hope that we can bring in the AI, ML, etc. We can build this prescriptives, etc. So I told my engineer, Opc Ua is the way to go when it comes to future prescribing the data architecture moving forward. Thank you.
Thanks. So Antonio, based on your experience in Industry 4.0, who is adopting Opc Ua and how?
If I'm able to make a distinction now and to bring in the discrete manufacturing, I would say that the level of adoption of Opc Ua in the discrete manufacturing is much higher than the one in the process industry. Maybe because the process industry, as also Shahrul highlighted, has to go through a management of change, which requires much more, let's say, time and much more consideration to be taken to be done. And also the legacy of of the assets it represents one of the biggest barrier, because it's not so straightforward that you can implement Opc Ua protocol or pulling out information in the Opc Ua from some PLC, from some of the assets. So that basically slow down the adoption in the process industry. Although there are some OEMs which are able to provide middleware that are able to extract the data to Opc Ua from these assets. But if I have to judge it from my own experience, I see the discrete industry as a faster user than the actual process industry in terms of Opc Ua.
Yeah, so there are many good solutions to migrate from classic OPC to new Opc Ua. So thank you for that perspective on the discrete automation there, manufacturing, Antonio. But so Michael, process automation. How do you see Opc Ua in process automation? Can we catch up?
Yeah. Absolutely, yeah, no doubt.
Yeah.
They one first indicator is NOAA. You've talked about that earlier, and the NAMO open architecture has very clearly specified Opc Ua as their channel, as their communication to maintenance and optimization to the cloud. I'm a bit surprised the first time that this term is mentioned today, and that's a very good indicator that Opc Ua will make its path into process industries. There are other activities coming from FDT, field device technology, or FDI, field device integration, and both have defined Opc Ua based interfaces. So actually they act as a bridge between existing instruments, hard instruments, will be a big bunch of that, and they basically represent hard instruments in an Opc Ua information model that's built into their architecture. The NOAA has also specified the PADIM. There's a standardized device information model for process automation field devices, and that allows a standardized approach on Opc Ua. Furthermore, when you look into Ethernet APL, I'm always coming back to that. This is an enabler to build the Opc Ua server into the field instrument. So the field instrument's gonna bring the information model with it, and that means seamless integration. No converters, no adapters, no configuration, no whatever. The information model pops up without any configuration. I think that's a very powerful feature, and that's only provided by Opc Ua. There's no other technology doing that. Antonio, you have mentioned the faster adoption rate in discrete manufacturing and factory automation. That there is one thing that's being worked on there. That's also real-time communication on Opc Ua, field level communication on Opc Ua. Opc Ua has real-time capabilities today, and I also see a chance that this also will make its way into process automation.
Yeah, I agree with you, Michael.
Ending up in an all Opc Ua operated plant.
I'm completely with you. I was just highlighting the current status of the adoption from our experience. I'm with you that Opc Ua is the way to go to enable the full integration of two-way communications. And also for M2M, Opc Ua is the enabler. For the implementation of NAMU architecture, Opc Ua, as you mentioned, is the enabler for the different layers to interoperate. And interoperability would basically be the way to go from my perspective.
So one technology that we didn't discuss so much, I just go first.
Jonas.
Yes, go ahead, Sharon.
Sorry. I would like to add to remarks from Michael and also Antonio. Because the Opc Ua is actually quite a powerful protocol, data exchange, standardized data exchange, and because of that, the DCS of the future this Open Process Automation Forum, an organization, an open group organization that is trying to come up with an open DCS, interoperable, secure by design by 2025. They have selected Opc Ua as the backbone of the Open Process Automation standards. This shows the importance that Opc Ua can offer, and this organization has selected this as the backbone. So which means it's like the heart of the state system. So it shows how important is this Opc Ua. Thank you.
Right. Yeah. So the one technology we didn't really have this time to discuss is MTP, but yeah, Opc Ua is also there at the core of the MTP. So gentlemen, we got 4 minutes to go. So can I have some 1 minute closing remarks from each one of you? Antonio, will you go first? 1 minute.
Okay, I believe that the world of technology is evolving to basically enable the plants, our process industry, to adopt Industry 4.0. But we also need to be aware about what will be the level of adoption and knowledge that is needed from the plant operators in order to make the full utilization of these technologies. We also need to make a strong risk, let's say, management approach when implementing such technology. So with the right care, I believe that also the process industry can reach a very, let's say, integrated and interoperable level of operation, optimized operation. But there are some factors that we need to really consider very, very carefully.
Thanks, Antonio. Sharul, closing remarks, 1 minute.
Oh, wow. 1 minute. Okay, the time is countdown. Okay. I'm looking from Petronas perspective. We have this what they call MFT, moving forward together, 50-30-0. By 2050, net zero carbon emission. Okay. By 2030, we need to have 30% revenue from the non-conventional, non-fossil fuel. By another 10 years, we need to have operational excellence with 50% increase in our revenues. So this technology is beautiful, but if the technology cannot help our vision, then it won't go. Okay, so we need to harness this technology towards reduction of the capex and the opex. And when come to this, for example, this APL, and when you are bringing the diagnostic all the way to the enterprise, we make the plant reliable. So we can achieve that. Thank you.
Thanks, Cheryl. Michael, 1 minute closing remarks.
Yeah, that's a hard task to do that in 1 minute. I just repeat my vision that communications will go IP for field instruments all over the plant, and I see that today's bottleneck to get hold of that diagnostic data that's so important for Sharul is the inhomogeneous infrastructure we've got today with all the domain-specific digital protocols and physical layers, and we need easy, simple access to the data, and therefore IP technology is enabling a flat architecture with no gateways, no protocol conversions that make such things a nightmare today. And furthermore, it also provides more bandwidth than we have today, and it will, and it also provides more power, more electrical power to the instruments, and that going to be also an enabler for more functionality in the instruments. So that we've seen that in many other domains, this is an enabler to add functions, and that will help in the future to be more efficient, to have plants that are running more efficient, to save mainly capex.
So, well, net zero is the goal. We're going to have to build a lot of new plants in units, carbon captures, electrolyzers, fuel cells, and all of these can actually benefit from the 5 technologies that we have spoken about today. You know, these technologies will make this much more affordable to build, so we can achieve these net zero goals. And I think that is the most wonderful conclusion we could have on this discussion. Thank you very much, everyone.
Thank you.
Thank you.
Thank you.